Simplify. Write in a plus bi form. Okay, so what do we have here? We have 11 minus the square root of negative 49, and we have 1 plus the square root of negative 81. Okay, so this gives us a hint that we have a complex number here, a plus bi. But we also know that because we know that the square root of negative 1 is defined to be I. So recall, the square root of negative 1 we define to be the imaginary number I. Okay. We also know what I squared is. So if we take, let's back up, if we take the square root of negative 1, which is equal to I, and then we square both sides, well, square root of negative 1 squared, when you have a square root and a squared, they cancel each other out because they're inverse processes. So we get negative 1 equals I squared. So we have two important properties we're going to use over and over and over again. They're going to help us clean this up. So at first glance, this may not look like it has any imaginary parts, but it certainly does because we have a square root of a negative number. So the square root of negative 49 can be rewritten as a product. The radicand, remember the radicand is what is under the root, can be rewritten as a product. So negative 1 times 49. Okay, we have a rule that says the square root of a times b, as long as they're not both negative, is equal to the square root of a times the square root of b. Okay, so again, as long as they're not both negative. So this is the square root of negative 1 times the square root of 49, which is I. And the square root of 49 is 7, so this is 7i. And then we can do the same thing with the square root of negative 81. That's the square root of negative 1 times 81. And again, if both things here, they both cannot be negative, a and b are not both negative. This is true, so we have the square root of negative 1 times the square root of 81, so this is I times 9, or 9i. So we're going to use that up here when we clean up. So this is the same thing as 11 minus 7i as my numerator, and the denominator is 1 plus 9i. And we want to write this in a plus bi form. Notice there's no fractions here, so I can't, this is not done enough, and I have i's on the bottom. I don't have that here. So when you want a plus bi form, you want a, and then plus or minus some number in I. If there's a fraction, this can be a fraction, this can be a fraction, but you can't have one big fraction. Okay, definitely can't have an I on the denominator. So I'm going to need to clean that up. Remember in your previous math classes, you may have multiplied through by a, what we called a conjugate. If you had a root on the bottom, you wanted to rationalize this. Rationalize meant get rid of the root wherever it was. If you wanted to rationalize the denominator, then you could multiply through by the conjugate of the denominator. So that's what we're going to do here. Remember, this is an expression. To clean up an expression, we're allowed to do two things. We can add 0 or multiply by 1. We're going to multiply by a special 1. We are going to multiply by what we call the complex conjugate. Okay? So, complex conjugates. Let's just review that for just a bit. Complex conjugates. You have a plus bi. Its complex conjugate is a minus bi. The value in the front is the same. The value in the back is the same. You just change the signs. Okay. So we're going to multiply through by the complex conjugate, and we've done a video earlier where if you have a plus bi times a minus bi, this is very similar to a difference of squares. If you look, the fronts are the same. The backs are the same, but the signs are different. So we're allowed to just clean it up very quickly to say, well, you square the front, square the back, and put a minus sign. Okay, so that's what we're going to do here. We're going to multiply through by the complex conjugate over itself. That way we're multiplying through by the number 1. So we're going to have 1 minus 9i. Do you see that's the complex conjugate? Keep the front the same, keep the back the same, change the sign in the middle. Okay. So 1 minus 9i. We are multiplying through by the number 1 because you have the same thing over itself. Now we're going to just spoil it. So first is 11 times 1 is 11. Outer is 11 times a negative 9i, or negative 99i. Inner is negative 7i times 1, so we have negative 7i. And last, we have a negative 7i times a negative 9i. So that becomes a positive. Well, 7 times 9 is 63, and you get I squared. And then we do the same thing with the bottom if we want to, or we can use this property right here. So we could FOIL it. If you want to FOIL it, go right ahead. The middle two terms, the outer and inner, will cancel. But you can remember this property, and you can just write it down. You square the front. You have 1 times 1, that's 1. You put a minus sign, and you square the back. So when you square the back, you get 9i times 9i, which is 81i squared. And we also know that I squared is equal to negative 1. So every time we see an I squared, we're going to write negative 1 instead of it. So we have 11 minus, okay, well in the middle here we have negative 99i and negative 7i. So we're just going to combine those because they both have I terms, right? So we end up with what? 106? Okay, so negative 106i. Okay, and then here I told you we're going to do 63, and instead of I squared, we're going to put a negative 1. See, that's what we've done right here. Okay, let's continue. On the bottom, I have 1 minus 81, and instead of I squared, what are we going to write? Negative 1. Okay. So, I'm going to keep cleaning it up. So we have 11 minus 106i. Now we have minus 63. And on the bottom, we have 1 plus 81, because you have a negative times a negative becomes a positive. We're going to combine the terms without i's. So 11 minus 63. So 63 minus 11 is what? 52. But we're going to use a negative sign because our bigger one was negative. Minus 106i. And the denominator is 82. But we wanted this in a plus bi form. And I told you earlier that was fine. We couldn't have a fraction. If we wanted a fraction, a could be a fraction or b could be a fraction. But not the whole thing. Okay, so we're going to write this in terms of two pieces. Let me remind you a rule from algebra. You have a over b plus c over b, and you want to combine them. If you would build a common denominator, you see they both have a b, so we rewrite the common denominator, and we combine the numerators. But this is an equal sign in the middle, so I can go this direction. I can also go this direction and undo it. So that's what we're going to do here. So we have negative 52 over 81 minus 106. I said 81, it should be 82. 52 over 82 minus 106 over 82 times I. And then we clean it up. We can reduce this, right? So 52 and 82 are both even for sure because they both end in an even number. So 52 divided by 2 is 26. So let's see, negative 26. 82 divided by 2 is 41. Okay, I think that's good. And we can do the same thing in the back for the back term, the I term. 106 and 82 are also both even. Divide both by 2. 106 divided by 2 was what, 53? 82 divided by 2 is 41. I. And you can't clean it up any further. And notice this is in a plus bi form.